Hello guys, welcome to this class for complex numbers. In this class, we'll discuss one or two small topics. One will be how do we take logarithm of complex number, and one I'll discuss how do we take square root of a complex number. And apart from that, we'll discuss some good problems which are based upon these topics, conjugate, modulus, argument, logarithm, square root. So this basic portion of complex number, those problems we'll discuss in this class. So first of all, how do we take logarithm of a complex number? See, we know z is equal to r e iota theta from the Euler form. If you take log base e both side, you get ln z, or log base ez is log r plus iota theta. So for the next time, what do you remember here? So log of a complex number will be log of its modulus plus iota time its argument. For example, log iota. So log iota, if you want to find out, you can see its modulus will be 1. So log 1 and its argument will be pi by 2. So iota times pi by 2. So log 1 will be 0. So 0 plus iota pi by 2, you get just iota pi by 2. Now, next problem you can try yourself. Find modulus and argument. This is supposed to be argument. Find modulus and argument of iota par iota. You can pause the video and give it a try. Let us start discussion now. So the answer here is argument of z will be 0, like this iota par iota if you take as z. So its argument will be 0 and modulus will be e power minus pi by 2. See, how do we solve this thing? So take z equal to iota par iota and take log both side. So log z will become iota outside, iota log iota. Now log iota, we discussed in the previous problem, is iota pi by 2. So into iota, you get what? You get iota square, which will be minus 1, so you get minus pi by 2. So log z is equal to minus pi by 2, so z is equal to e power minus pi by 2. You can say e power minus pi by 2 is a purely real number. It's an exponential function. There's no iota and all here. It's a purely real, and it will be a positive number also. So purely real positive number, so argument will be 0 and mod will just be the number itself, that is e power minus pi by 2. So this is a good problem. And one more thing you see here. See, z was iota par iota, which finally came out to be e power minus pi by 2. So if I ask you ever a complex number raised to power complex number, can this thing be real? Yes, it can be real, you see here. If someone asks you a complex number raised to power complex number, or this is imaginary number, some z is an imaginary number raised to power imaginary number, can this be real? Yes, it can be real. This is example. So imaginary number raised to power imaginary number come out to be a real number. Okay guys, now moving on to the set of problems. So all of you will give them try and then we'll match the answer and discuss the solution. So first one is find ordered pairs x comma y for which x square minus y square minus iota 2x plus y is equal to 2 iota. X and y are real numbers. You can pause and give it a try. Let us start discussion now. So the correct answer is minus 2 by 3 comma minus 2 by 3 and minus 2 comma 2. There are two pairs. How do we solve them? You can see complex number. If this complex number is equal to this complex number, so the real part must be equal, imaginary part must be equal. So real part on the right side is 0 only and the left side is x square minus y square. So you get x square minus y square equal to 0. And imaginary part here equate to imaginary part here, you get 2xy equal to minus 2. Then you can just solve the equation. So x will be plus or minus y. So if you take x equal to plus y, you get both minus 2 by 3 from here. And if you put x as minus y, it'll come out to be minus 2. So these two are the solutions. Okay, easy problem. Next one, guys. Z square minus 3 plus iota z plus m plus 2 iota equal to 0, where m is a real number if one root is purely real. So for this quadratic, if one root is purely real, find m and the roots of the equation. So pause and give it a try. Let us start discussion now. So the final answer for this problem is m is 2, roots are 2 comma 1 plus iota. So if you are not able to solve, see this thing. Let us say z equal to k is the real root, so k will be a real number. Put it here, you get k square minus 3 plus iota k plus m plus 2 iota equal to 0. Now equate the real part to 0, equate the imaginary part to 0. So you get k square minus 3k plus m equal to 0 and minus k plus 2 equal to 0. So k will be 2 from here. When you put k as 2, you get m will be again 2. So the real root will be 2 and m is also 2. When you put m as 2 in the given equation, you get z square minus 3 plus iota z plus 2 plus 2 iota equal to 0. So sum of roots we can use here. So the sum of roots, one root we know is 2 only. The k was 2, no? And other root is a beta. So 2 plus beta will be equal to 3 plus iota. Sum of root, product of roots formula will be same. So 2 plus beta is 3 plus iota. So beta will be 1 plus iota. So roots are 2 and 1 plus iota. I hope it is clear, guys. Next problem. See, we think if z is equal to 4 plus iota root 7, find the value of z cube minus 4z square minus 9z plus 91. It's a good problem. So give it a try. Let's start discussion now. See, what do we have here? If if z is equal to 4 plus iota root 7, you don't put it directly and try to solve. That will become too typical. We have a shortcut here. What do we do? First, if z is 4 plus iota root 7, I can say z minus 4 will be iota root 7 and then square both side. So z minus 4 square will be minus 7. So z square minus 8z plus 23 will be 0. Now you have to find out the value of this thing. So divide this polynomial by this thing. You know the long division method, this z cube minus 4z square minus 9z plus 91 divided by this quadratic. Finally, this will be quotient, this will be remainder. So now we can write this number z cube minus 4z square minus 9z plus 91 as z square minus 8z plus 23 into quotient plus remainder. And we already know this value is 0. So this thing will come out to be 0. We will just left with minus 1. So the final answer will just be minus 1. This is a good concept, guys. So for any of these kind of problem, you always use this method only. It will save you time. Next one, guys. We have iota z cube plus z square minus z plus iota equal to 0. Find mod z. So again, pause and give it a try. Let's start discussion now. See, first of all, if you see this equation, for the first two terms, if I take iota z square common, you get z minus iota only. If you take iota z square common, we get z minus iota. Just a moment. And from these two terms, if you take minus 1 common, you get z minus iota. So basically, factorize here. You get z minus iota z square minus 1 equal to 0. So either z is iota or iota z square is equal to 1. So if z is iota, mod z will be 1. And if iota z square is 1, so if it is an iota this side, you get z square as minus iota. Again, if you take mod both side, you get mod z square equal to 1 and mod z can be 1 only then. Mod z cannot be negative because the distance, if you remember, so mod z has to be 1. Next problem, guys. Find number of complex numbers z which satisfy these two conditions. Okay, both the conditions must be satisfied. Real of z square equal to 0 and mod z is root 3. Can give it a try. The correct answer here is 4 complex numbers will be there. How you can solve this thing? Take z equal to x plus iota y. So z square will be x square minus y square plus 2xy iota. So real of z square is 0. So x square minus y square is 0. So x will be plus minus y. And mod z is root 3. So x square plus y square will be 3 also. So you get x could be plus minus root 3 by 2. Y could be plus minus root 3 y2. All the possible combinations will be there. So 4 answer we'll get. Next problem. Now this is interesting problem. This might spin your head also. Z equal to iota ln 2 minus root 3. Find the value of cos Z. Z is iota ln 2 minus root 3. Find the value of cos Z. Can give it a try, guys. Let's start discussion. The answer for here will be 2. Cos Z will be 2. So you might think that how cos Z can be 2. Cos range is minus 1 to 1. See, cos range is minus 1 to 1 when domain is all real number. So when domain is real numbers, then we can say the range of cos x is 1 minus 1 to 1. But in complex numbers, sky is the limit. You can have anything. How do we solve this thing? See, guys, we discussed this e iota theta thing, no? So if I have e iota z, it will be cos z plus iota sine z. And e minus iota z will be cos z minus iota sine z. Okay, just in place of like this formula we discussed, e iota theta as cos theta plus iota sine theta. Put theta as z and minus z, you end up with these two results. So how do you find cos z from here? Add these two. You get cos z will be e iota z plus e minus iota z divided by 2. And z is this thing. So when you put here, you get e power minus ln 2 minus root 3 plus e power ln 2 minus root 3 by 2. And this thing, when you solve, will come out to be 1 by 2 minus root 3. If you rationalize, you get 2 plus root 3. This will be 2 minus root 3. You get 2 only, so cos z will be just 2. Okay, do remember, guys, in complex numbers, there is no range and all. It could be anything. Next, now again a very good problem. We have iota raised to power iota up to infinite times equal to x plus iota y. X square plus y square is equal to e power y whole power k. Find the value of k. It's a good problem, guys. Give it a try. Let us start discussion now. See, you take this, this, I think, how do we solve this infinite series and all? If this is x plus iota y, we can say the power of iota will also be x plus iota y only. So iota power x plus iota y will be equal to x plus iota y. Take ln both sides. We get x plus iota y into ln iota equal to ln x plus iota y. Now ln iota we discussed already is iota pi by 2 into x plus iota y. And this side is have a complex number. I told you ln of a complex number will be ln of its modulus plus iota times its argument. If you simplify the left side, you get iota x pi by 2 minus y pi by 2. Right side, take half outside. Half ln x square plus y square plus iota argument x plus iota y. Now compare the real part. So real part of the left side will be minus y pi by 2. And right side is half ln x square plus y square. So this half and half cancel. X square plus y square will be e power minus y pi. So k will come out to be minus pi. I hope it is clear, guys. Next problem. Saying tan of, now this is a normal bracket, not any fractional part or anything. It's normal bracket, guys. Tan iota log a minus iota b by a plus iota b is x plus iota y. Find x comma y. So again, pause and give it a try. Let's start discussion now. See, take a minus iota b to be z with the argument theta. A minus iota b to be z with the argument theta. So a plus iota b will be z bar then conjugate with argument minus theta. Log a minus iota b is log mod z plus iota theta. So log a plus iota b will be log z bar mod minus iota theta. If you subtract them, you see this will be same, get cancelled out. So log a minus iota b by a plus iota b will be just 2 iota theta. So tan iota of, like, this thing come out to be 2 iota theta. So you get tan iota 2 iota theta. There will be tan minus 2 theta, which is minus tan 2 theta. So which will be minus 2 tan theta by 1 minus tan square theta. We don't have enough information about the signs and all, where do A and B lie. This is the normal case we are taking. Tan theta is minus B over A. Okay, I'm just taking the normal case that if x plus iota y is there, I'm just assuming that argument of z will be just tan inverse y by x, because we have no information about A and B. So tan theta will just be minus B over A, because this was a complex number. So when you put that here and simplify, you get 2ab by a square minus b square, which is a purely real number. So x will be 2ab by a square minus b square and y will be 0. So again you can see final answer is purely real. Okay, I hope it is clear, guys. Next one. Now this is a very good problem. Z equal to 1 plus iota tan theta in polar form. So you have to write Z equal to Z, which is 1 plus iota tan theta in polar form. But first scenario is theta belongs to pi by 2 to pi. Okay, polar form we have to write this into, and theta belongs to pi by 2 to pi, and z is 1 plus iota tan theta. This is very important problem, guys. This kind of thing they do ask in mains directly. So pause the video, give it try, the first part. The answer for the first part is, if you remember, I will write this as r cis theta. So here you get minus secant theta cis theta minus phi. So basically the modulus is minus secant theta and argument is theta minus pi. How do we get this thing? I'll explain the first part. You can try the second part then. See, theta belongs to pi by 2 to pi. Now this is theta. It is not the complex number which lies in this. Theta belongs to pi by 2 to pi. That is second quadrant. So tan theta will be negative. So if you see this complex number, coordinates are 1 tan theta. So if tan theta negative and you see x is positive, so complex number will lie in fourth quadrant. Now the mod z will be a square root of 1 plus tan square theta, which will become mod secant theta. Now theta's second quadrant will be negative, so mod will be minus secant theta. Now, how do you find alpha? If you remember, tan inverse mod y by x, you'll get tan inverse mod tan theta. This tan theta is negative, so mod open with a negative sign, negative come outside, you get minus tan inverse of tan theta. Now, tan inverse of tan theta, if theta belongs to pi by 2 to pi, you must have gone through ITF class by now. If you have not, do look into that. That is very important. Otherwise, you'll not be able to solve these kind of things. So in theta belongs to pi by 2 to pi, tan inverse of tan theta will be theta minus pi. So finally get pi minus theta. That is your alpha value. And argument of z will be minus alpha because it lies in the fourth quadrant. So it will become theta minus pi. So mod is minus secant theta, argument is theta minus pi, so complex number will be minus secant theta cis theta minus pi. I hope it is clear, guys. Take a look again otherwise, and then try the second part yourself. Pause the video. Let us start now. Second part, we get minus secant theta cis theta plus pi. So here mod is same, minus secant theta, but argument is theta plus pi. See how? So theta belongs to minus pi to minus pi by 2. You will see this is nothing but third quadrant where tan will be positive. So tan is positive. The coordinates were 1 comma tan theta. So complex number will lie in first quadrant. Mod z will be again mod secant theta, third quadrant, secant negative. So minus secant theta. And alpha will be tan inverse of mod tan theta. Tan theta now positive. So tan inverse of tan theta. And if theta belongs to this interval, so tan inverse of tan theta will come out to be theta plus pi. Again, ITF thing. And argument of z in this case will be alpha because z lies in the first quadrant, so theta plus pi. So z is minus secant theta into cis theta plus pi. I hope it is clear, guys. This is very important problem. Let us see the next one. Now this range problem they ask many a times, so do look into this thing. This is a very important problem again. Mod z minus 4 by z is 2. Find the range of mod z. Okay, pause the video, give it a try. Let us start discussion now. Here we'll use the inequalities we discussed in the last class. Mod z we can also write as z minus 4 by z plus 4 by z. Basically just adding 4 by z, subtracting 4 by z. Just change the color here, will give you better idea. And here we'll use this. This is z1, this is z2. So z1 plus z2 mod is less than equal to mod z1 plus mod z2. So this thing will be less than z minus 4 by z mod plus 4 by z mod. And you know this value is just mod z only, less than equal to. This value is given as 2 already. So we get mod z less than equal to 2 plus 4 by mod z. Take LCM, we get mod z square minus 2 mod z minus 4 less than equal to 0. When you use wavy curve thing, the roots will be 1 minus square root 5 to 1 plus square root 5. Positive, negative, positive. You want less than equal to 0, so you should lie between the roots. But you see, mod z cannot be negative, so we need not start from here. We can just start from open 0. So mod z will belong to open 0 to 1 plus square root 5 close. Why open 0? Because mod z will be 0 only if z is 0. And z0 we cannot take here, no, because z we have in the denominator. So final answer is open z to 1 plus square root 5 close. I hope it is clear, guys. Next. Some more theoretical problems. Mod z1 is equal to mod z2 equal to mod z3 up to mod zn, which is 1. All are 1. Mod z1 plus z2 plus z3 up to zn is 4. Find the value of 1 by z1 plus 1 by z2 up to 1 by zn mod. So pause the video, give it a try. Let's start discussion now. Final answer here is 4. See, a very good point here. Mod z square, if you remember, is z into z bar. So whenever mod z will be 1, so z into z bar will be 1. So they'll be reciprocal of each other. So 1 by z we can write as z bar, or 1 by z bar you also can write as z. So 1 by z1 we can write as z1 bar. 1 by z2 we can write as z2 bar. And z1 bar plus z2 bar plus zn bar we can write as z1 plus z2 up to zn whole bar. And mod of z bar is equal to mod of z only. So this is 4, so this will also be 4. So final answer is just 4. Okay, so this point is very, very important, guys. Will be used in many problems. Whenever mod z is 1, they will be reciprocal of each other. Okay, guys, next. Two power 104 by 7 power 115 into z2 by z1 is purely imaginary. Find the value of 2z1 plus 3z2 by 2z1 minus 3z2 whole mod. This problem, similar kind of problem was asking G means, so give it a try. Let us start discussion, guys. Final answer is just 1. How do we see this thing? First of all, if a number is purely imaginary, this number. You see, if I like divide by 2 power 104 and multiply by 7 power 115, this number will still be purely imaginary only, no? So I can say if this is purely imaginary, that means z2 by z1 must be purely imaginary because this is a constant real part. And if z2 by z1 is purely imaginary, I can write this as like k iota. Here k is some real number. Now they're asking this thing divide both by z2. So divide both by z1. So you get 2 plus 3 z2 by z1 by 2 minus 3 z2 by z1. Z2 by Z1 is k iota, so you get 2 plus 3 k iota by 2 minus 3 k iota. If I take this numerator as z, the denominator will be nothing but z bar. So mod z by mod z bar, both are equal, so just be 1. Okay, if I take this as z, this is nothing but conjugate of that. I hope you remember conjugate. Okay, guys, next problem. Find the minimum value of mod z plus mod z minus 1. I'll discuss this problem myself also. See, we discuss this inequalities at z1 plus z2 mod or z1 minus z2 mod will always be less than equal to mod z1 plus mod z2. If you use it here, in place of z1 you take mod z, in place of z2 you take z minus 1 mod, it will be greater than equal to, when you subtract them you get just 1. So from there you get directly mod z1 plus mod z minus 1 is greater than equal to 1, so minimum value is 1. Now, what is other way around? If you remember in the class, I told you mod z is the distance from origin. And if you see mod z minus 1, it will be distance of z from the point 1 comma 0. Mod z is distance from origin. You can see like z minus 0 mod plus z minus 1 mod. So this is nothing but distance from the point 1 comma 0. If I give you z minus iota mod, this will be distance from point 0 comma 1. If I give you z minus 1 plus 2 iota mod, it will be distance from the point 1 comma 2. This thing in detail we'll discuss in the next week or like second week of complex numbers, but in this problem it will be helpful. So if I take point P as Z, A will be origin 0, B is the point 1 comma 0, so this is nothing but PA plus PP. And if we have like 2 points A and B, now PA plus PB, like P is some point in the plane, the sum of distances will be minimum when P will lie between AB. Then PA between as in like it could lie anywhere on the line segment. In that case, PA plus PB will be equal to AB. If I take P anywhere else, PA plus PB will always be more than AB using the triangle law. If it lies between AB, PA plus PB will be equal to AB. If it lies outside anywhere in the plane, PA plus PB will be more than AB. So minimum value of PA plus PB will be AB, which is 1. AB is the distance between A and B. That will just be 1. Okay, so if this thing is not very clear, no problem. In second week of complex number, we'll discuss this geometry in detail. That time you will be able to understand this. For now, next problem. Again, a theoretical problem we have. Mod z1, mod z2, mod z3 are 1. Find the maximum value of z1 minus z2 mod square plus z2 minus z3 mod square plus z3 minus z1 mod square. Okay, you can give it a try. Let us start discussion. The correct answer here is 9. See how. First of all, we have discussed this thing z1 minus z2 mod square. We can write as z1 minus z2 into z1 bar minus z2 bar. When you multiply them, you get z1 mod square, which will be just 1. So you get 1 plus 1. This should have been negative here. Minus z1 z2 bar minus z1 bar z2. So same way, if you open all three, you get this will be like 2 here. So when you do all three, you get 6 minus z1 z2 bar plus z1 bar z2. Same for z2 z3. Same for z1 z3. Now we can also say z1 plus z2 plus z3 mod square will be greater than equal to 0. Basically, any mod square will be greater than equal to 0 only, no? So how do we open this thing? Again, same. Z1 plus Z2 plus Z3 into conjugate of that. When you multiply them, you get 1 plus 1 plus 1 plus again all the pairs. Z1 Z2 bar, Z1 bar Z2, and do same for all. Now, you're looking for this minimum value of this thing will come out to be minus 3. Now, you want the maximum value of this. This is 6 minus something. So you can say this will be maximum when this negative term is minimum. And minimum value of this thing is minus 3. When you put minus 3 there, you get 6 plus 3, 9. So maximum value of this thing will be 9. It is greater than less than equal to. Okay, so this thing is maximum when this thing is minimum, which is minus 3 here. When you put minus 3, you get maximum value of this thing to be 9. And you can see that it will be maximum when this thing is equal to minus 3. And this will be equal to minus 3 when this thing was 0. And this thing z1 plus z2 plus z3 When it is 0, then you get this thing to be maximum equal to 9 under the condition that mod z1, mod z2, mod z3 are all 1. Okay, I hope it is clear, guys. Next. And this is the last problem in this section. Mod z1 equal to mod z2 equal to mod z3 equal to 1. z1 plus z2 plus z3 is root 2 plus iota. Find the real part of z1 by z2 plus z2 by z3 plus z3 by z1. Okay, guys, you can pause the video, give it a try. Let us start discussion now. So answer for this problem is 0. So if you are not able to solve, let us see now. Again, when mod z is 1, 1 by z is z bar. So z1 by z2 we can write as z1 z2 bar. Sorry, z1 z2 bar plus z1 bar z2. This we can write as z1 z2 bar plus z1 z2 bar whole bar also, no? You see this thing? Because z bar of bar will be z only, no? So now a complex number plus its conjugate, if you remember, z plus z bar gives you 2 times real part of that. So get 2 times real of z1 z2 bar, and z2 bar we can write as 1 by z2 also, no, using this thing. So z1 z2 bar plus z1 bar z2 we can write as 2 times real of z1 by z2. Okay, this will be helpful now solving problems. So we have z1 plus z2 plus z3 is root 2 plus iota. Take mod square both sides. So this mod square will be just 3, 2 plus 1. And this left side you get 1 plus 1 plus 1 plus z1 z2 bar plus z1 bar z2 and also on. Just like we discussed in the previous problem. So this 3 and this 3 will get cancelled out, and this z1 z2 bar plus z1 bar z2 will be 2 times real of z1 by z2. So next we can write 2 times real of z2 by z3. Next we can write 2 times real of z3 by z1 equal to 0. And if you have real of z1 plus real of z2, you can write this thing as real of z1 plus z2. Same thing will be there. So you can say if 2 also just vanish here, divide by 2 both sides, you get real of z1 by z2 plus z2 by z3 plus z3 by z1 will be equal to 0. This is the final answer here. Okay, guys, next. Next, we'll discuss how do you find square root of a complex number. See, guys, square root of a complex number is different from one we do in the real functions. If you remember in real function, if I say what is square root of 9, it is just 3. That's all. There we discuss square root as a function that it takes only positive values and gives only positive value. And function always gives you only one value. But here it is not like that. If you say square root of a complex number is different from one in the real function, how? Here, if I say square root of a plus iota b is equal to z, it just simply means that if you do z square, you get a plus iota b. That's all. So here, if I say square root of a plus iota b is z, that simply means z square will be a plus iota b. This is not applicable in the real functions because there I say square root of 9 equal to 3 only. If I use this definition, then square root of 9 will be plus minus 3 then. Okay, that square root function of real function was different. Here it is different. And if you have z square equal to a plus iota b, you can see this is a quadratic equation. So it must have two roots. If you know z square equal to something, so z will be plus minus of that, no? So there will always be two roots or two values of square root of a complex number. Okay, how do we find them? I'll just give you a simple procedure here. So square root of a plus iota b is assumed to be x plus iota y, and like we discussed, there'll be two pairs finally. Now square both sides, you get a plus iota b equal to x square minus y square plus 2xy iota. Compare the real part, so a will be x square minus y square. Compare the imaginary part, b will be 2xy. Now, if b is positive, then xy will be of same sign. And you can see if b is negative, then x and y will be of opposite sign. So this point will be used later, so we'll keep in mind. Now we have this much information. Now I can say x square plus y square whole square. We can write as x square minus y square whole square plus 4x square y square. just normal identities. So using the add, you get x square plus y square as, now this value is a, this value will be b square. So you get a square plus b square square root of that. Because x square plus y square, x and y are real numbers, sum of square will be positive only. So we need not take plus minus here. So x square plus y square is root a square plus b square, and x square minus y square is a. Now you add and subtract to get x square as root a square plus b square plus a by 2, and y square as root a square plus b square minus a by 2. So now x will be plus or minus root of root a square plus b square plus a by 2. Y will be plus or minus root of root a square plus b square minus a by 2. Now you will say plus minus here, 4 cases. No, there will not be 4 cases. You see this plus minus sign will define if the value of x is positive or negative. What values we can take will depend upon the sign of b. See, if b is positive, then xy of same sign. So we'll take one case by taking both positive and one case by taking both negative. And if b is negative, then xy will be of opposite sign. So if I take x positive, I'll take y negative, and when I take x negative, I'll take y positive. Okay, so you can remember this direct result also. I'll show you with the help of example. What do I mean by this? So the formula you remember, like it's root a square plus b square plus a by 2, root a square plus b square minus a by 2, whole under square root. The first problem is square root of 3 plus 4 iota. You see a here is 3, b here is 4, and b is positive, so x and y have same sign. Using the formula, I get x equal to plus minus root of, so if you remember, root a square plus b square plus a. So root a square plus b square will be 5, so 5 plus 3 by 2, so x will be plus minus 2. And here you get 5 minus 3 by 2, so y will be plus minus 1. And x and y must be of same sign, so you get answer will be 2 plus iota and minus 2 minus iota. Okay, I hope it is clear, guys. Next, if you do it for 3 minus 4 iota, square root of 3 minus 4 iota, here a is 3, b is minus 4, b is negative, so x and y are of opposite sign. So same here, x will be plus minus 2, y will be plus minus 1. But now because b is negative, now we take roots, or the final answer be 2 minus iota and minus 2 plus iota. I hope this clarify all the doubts you have about this b and xy thing. So you can remember the formula, I can use it directly for these kind of problems, and just try one more question on yourself on this. A conceptual problem, this is root of x plus iota y is plus minus a plus iota b, then find square root of minus x minus iota y. You can pause and give it a try. Let us start discussion now. See, the final answer here is plus minus a iota minus b. So if you have got this thing, good. If otherwise, you can look into the solution. So we have square root of minus x minus iota y, take negative common, and root of minus of, say, a, if we have, we can write as root of a into iota, no? It's like root of minus 1 into root of a. So you get iota time square root of x plus iota y. This is plus minus a plus iota b. Take iota inside. You get a iota minus b plus minus outside. Okay, that is all. So this is all for this class. We have covered logarithm, square root, and some good problems for the first week of complex numbers. That is all for now, guys. Bye bye.